welcome. My name is Erin Prasner, a 5th grade teacher at Runnymede Elementary. Today let's focus on finding whole number quotients. This time we're going to, division can be represented many different ways. So rather than straight division, starting with a divisor divided by a dividend and showing you the computation, I'd like to show you how we can represent division by matching an equation to a model. And the problem that I'm addressing today is represent this model with a division equation. But before I show you how to generate an equation that matches this model, let me first take a minute to introduce you to what this model is. This is a drawing on grid paper of something that can also be built with digiblocks in the classroom. And it's been divided into several different parts. We've got one big rectangle, which I'll come back to in a minute. Within that big rectangle, we've got hundreds. And why does this represent 100? Well, it's 10 across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, by 10 down. And of course, 10 times 10 gives us 100 total squares inside this larger square that I have outlined. Meanwhile, we also have these long rods that represent tens, and they're just 10 singles going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of these are our tens. We've got tens down here. And then finally, you can see that we've got single squares outlined that represent ones. So within our base 10 system, we've got our hundreds, our tens, and our ones. All put together, that represents a number within our big rectangle. Okay, so back to our problem, represent the model with a division equation. We can represent this model as a single number, as a single quantity, by counting up the hundreds, tens, and ones. We can also represent it as an equation by using what we know about area is equal to length times width. Okay, so let's start first by counting the quantity of our total inside the big rectangle. Like I said a minute ago, each of these represents 100, so we have 100, and another 100, and another 100, and another 100. We have a whole bunch of tens. And of course, these can be regrouped into more hundreds, which we'll do in just a minute. And then finally, we've got our ones. And just as tens can be regrouped to make hundreds, we can regroup our ones to make tens. Okay, so right now we've got 4 100s, we've got 400. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 tens, or 240. 24 times 10 gives us 240. And then finally we have 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 3, we've got 27 ones. Add that all together, and our total quantity represented inside our giant rectangle is 667. Of course, the problem doesn't say to represent it as a single quantity, it says represent it as a division equation. So now how can we take all of this, knowing that it's 667, and represent it as a division equation? Let's go back to our area is equal to length times width. Since we're talking about a rectangle model, the inside is 667. That's like our area. We can also find the length and the width by counting across the top for our width, across the side for our length. So here I know I've got 10, and 10 makes 20, 21, 22, 23. Width of 23. Down the side, I've got 10, and 10 more makes 20. 1, 2, 3, 4, 5, 6, 7, 8, 9. Length of 29. So to complete our equation, area of 667 is equal to length of 29 times width of 23. And then your student or your child just has to use their prior knowledge of the relationship between multiplication and division to turn this into a division equation. There are two possible correct answers for this one. You could start with the area, 667 divided by 29 is equal to 23. That's one possible matching division equation that fits our model. The other one would be 667 divided by 23 is equal to 29. Both of these would be correct equations that represent our model. And that's representing a model as a division equation.